Hello everyone. Today we'll be looking at some quick solutions of All India AATS Test Series JEE Advanced 2019 Test 2A Paper 1 Code C and D. So let's start with the first section. Students, this section contains 6 multiple choice questions. Each question has 4 options, out of which only one single option is correct. So let's start with question number 21. We know that metals like sodium produces coloration when they are put over the flame. So the examiner seems to be interested in the flame coloration by the alkali metals. So which of the following is true regarding the above mentioned phenomena? Let us look at the statements given to us. Statement A says the wavelength of light which is emitted increases on moving from Na to K. So students, if we talk about the emission spectrum of sodium and potassium, so sodium produces yellow coloration in the flame, whereas potassium, it produces violet coloration in the flame. So if we talk about the spectrum, so we have Vibgyor, and as we move from left to right, we know that the lambda increases. So potassium, which produces violet coloration, is at the beginning, whereas sodium, which produces yellow coloration, is towards the end. So we can see that as we move from Na to K, the value of lambda should decrease. So students, statement A is incorrect. It does not increases. It in fact decreases from sodium to potassium. Let us look at the B statement now. Lithium and magnesium do not give flame test. So students, this statement is also incorrect. Lithium does in fact give the flame test. It gives red coloration to the flame. It is magnesium which does not react. So statement B is also incorrect. Let us look at statement C now. The spectra of the above phenomena is an example of absorption spectra. So students, we see the color which is emitted. So it is not an absorption spectra, it is an emission spectra. So we have to select option B as the correct answer to this question. Let us move ahead to the next question. Question number 22. Nitric oxide is paramagnetic in the gaseous state. Students, if we draw the structure of nitric oxide, we have an odd electron species. So we can either have the odd electron over nitrogen or we can have the odd electron over oxygen as well. These will be the two resonating structures. So NO has 15 electrons in its orbitals and it is an odd electron molecule. So it will be paramagnetic in the gaseous phase. But the examiner further tells us that it becomes diamagnetic in the solid state. So students, what happens is in the solid state, it forms a dimer. So due to formation of that dimer, the electrons in the odd electron molecule gets paired up and hence the paramagnetism is lost and the dimer, it becomes diamagnetic. So if we look at the options, we can see that the correct statement is given in option A, that the diamagnetic nature of NO2 can be attributed to the formation of a loose dimer in the solid state. So students, we have to mark option A as the correct answer to question number 22. Let us look at the next question, question number 23. Consider the structure of SO3 and observe the following statements. So in statement 1, the examiner talks about the bond angle in SO3 is not equal to 120, but ideally it should be 120. So students, this statement is incorrect. If we talk about the structure of SO3, the sulfur atom has 6 electrons and all of those 6 electrons are involved in forming bonds with oxygen. So we can see that the sulfur atom is sp2 hybridized and the bond angle here are 120 degree each due to symmetry. So statement 1 is incorrect. It says that it is not equal to 120 degree. Let us look at statement 2 now. The difference in bond angle is due to two different type of pi bonding in SO3, that is one is p pi and the other two are p pi d pi. Students, this statement is partially correct. The examiner is correct about the bonding type, but the statement becomes incorrect as it is mentioned that the bond angles are different. So this is not correct again. Let's look at statement 3 now. The difference in bond angle, this statement is also incorrect, students. There is no difference in the bond angles. The bond angle is exactly equal to 120 degree and only the fourth statement is correct out of these. So if you look at the option, we have to mark option D as the correct answer to our question. Let us look at the next question, question number 24. Consider the following statements which are about the properties of the D block elements. Statement 1. Chromium, molybdenum and tungsten. All three belong to the same group. This is correct. So number of electrons in Ns and N-1 D subshell in all three is equal to 1 and 5 respectively. Students, we know that the configuration of chromium is 4s1 3d5. Similarly, molybdenum also follows the same pattern. It is 5s1 4d5. However, if we talk about tungsten, which should be 6s1 5d5 as per the configuration of the group, but students, this is not observed. Tungsten has a configuration of 6s2 5d4. So statement 1 is incorrect. This can probably be explained by the fact that the energy released due to the shifting of electron into the 5d orbital is not sufficient enough to cause unpairing in the 6s orbital. Let us look at statement 2 now. There is a large difference between melting points of Fe, Co and Ni. Students, this statement is also incorrect. The melting points of these species are almost similar. There is not much difference between them. So statement 2 is also incorrect. Let us look at the third statement now. If the size difference between Cr and Mo is x units and between Mo and W is y units, then the value of y is greater than x in the same units. So we have Cr, Mo and W. So Cr belongs to period number 4. Molybdenum belongs to period number 5 and tungsten belongs to period number 6. So it is mentioned to us that the difference of size between Cr and Mo is x units, whereas the difference in size between Mo and W is y units. So students, it is mentioned to us that the value of y is greater than x, which is absolutely incorrect, as due to filling of the f orbitals, the size almost remains the same. So there is not much difference between the size of Mo and W, whereas there is still a greater difference in size between Cr and Mo as compared to Mo and W. So this is because of the poor shielding of the D and F orbitals. So statement 3 is also incorrect, students. So the examiner is interested in knowing about the statements which are incorrect in the question. So we have to mark S1, S2 and S3 for this question. So the correct answer to question number 24 is option D. Let us look at the next question now. Question number 25. You have been given some oxides of nitrogen. Consider their structure, geometry and the resonating forms. These oxides are N2O, NO, N2O3 and NO2. Which of the following is the incorrect statements? So students, let us first try and draw the oxides. So we have N2O first. So N2O has majorly two contributing structures. There is a coordinate bond between N and O, which can undergo resonance to form the second structure. So this is the structure of N2O. Let us look at the structure of NO now. So NO, as we had already seen before, has this structure. Let us look at N2O3 now. So N2O3 is a dimer of NO and NO2. The odd electron of N in NO as well as the odd electron of N in NO2. They form a bond together, forming N2O3. And lastly, we have NO2. So the NO2 structure also has an odd electron. So now let us look at the options. The examiner is interested in knowing the incorrect statement. So option A, bond length of Nn in N2O is greater than that in N2O3. Students, if we compare the Nn bond length in N2O, so the Nn bond length in N2O has a bond order somewhere between 2 and 3 as per the most stable resonating structures, whereas in N2O3 the Nn bond order appears to be 1. So students, the bond length in N2O3 should be greater than that in N2O. Students, statement A is incorrect. Let us look at statement B now. In N2O3, each nitrogen is sp2 hybridized, but the bond angle of O and O is around 130 degree. Students, this statement is correct. The nitrogens are both sp2 hybridized and the O and O bond angle is around 130 degree. Let us look at statement C now. The bond length of NO in NO2 is almost equal as in N2O. Students, if we look at the structure of NO2 and N2O, so both NO2 and N2O have a coordinate bond between N and O, which can undergo resonance. So their bond lengths are expected to be almost similar. In fact, they are very close. There's a difference of approximately 1 picometer between the two bond lengths. So students, the statement C is also correct. Let us look at statement D now. ONO bond angle is greater in NO2 as compared to N2O3, and there are two different ONN bond angles in N2O3. So let us first look at N2O3. So in N2O3, the examiner is telling us that there are two different ONN bond angles. That is true. So we have an ONN bond angle of this one. Also, we have an ONN bond angle of this one. So there are two different types of ONN bond angles. So this part of the statement is correct. Let us now compare the ONO bond angle, which the examiner is interested in. So the examiner is telling us that the ONO bond angle in NO2 is greater than that compared to N2O3. Students, this part is also correct, as there is a group which is causing repulsion in these bonds. So this will cause the bond angle to become lesser, as opposed to the single electron which is present in NO2, which does not cause as good repulsion as a proper bond pair. So students, in this question, we have to select the incorrect statement. So we have to mark option A as the correct answer to our question. Let us look at the next question. Question number 26. For the detection of nitrate ion, it is first treated with small quantity of metal sulfate solution, which is further tested for brown ring formation at the junction of two liquids. In which of the following condition we will get the brown ring test for NO3 minus ion? So option A, if ferric sulfate is used in the above test in place of metal sulfate X. So students, for the formation of the brown ring complex, we need ferrous ions. So Fe2 plus ions are required, which convert the NO3 minus into NO. In absence of the Fe2 plus ions, this nitrate to NO conversion will not take place, and hence the brown ring formation will not take place. So ferric sulfate cannot be used. Let us look at option B now. If ferrous sulfate is used in the above test in place of metal sulfate X. So students, ferrous sulfate can be used as it contains Fe in a state of +2. So this is correct. Let us look at the C part now. Ferric salt is treated with SO2 in aqueous medium, and then the reaction mixture is allowed to react with NO3 minus ion. Students, SO2 is a good reducing agent, and it converts the ferric ions, Fe3 plus, which was present in the form of ferric salt, is converted to Fe2 plus, which can then further react with the nitrate ion to give us NO. So students, this statement is also correct. So out of the given statements, the reactions given in statements B and C are correct. So we have to mark option C as the correct answer to our question.